Okay, good evening, ladies and gentlemen. I hope you're okay. It's been a while since we made a video for you guys, yeah. So today I decided to make a video to discuss the brief idea behind Model 3 right now. Model 3 is all about finding the equation of lines. That's what Model 3 is about. So we are looking at the general concept of lines per se, right? So you're looking at how to find the vector equation of a line. You're looking at how to find how to find the vector equation of a line, how to find the point of intersection between two lines. You're looking at if two lines intersect, what's the angle between them. You're looking at how to find the normal form of an equation of a line. So everything that we do in Model 3 is all about lines and the concept behind it. Okay, so we're going to begin with a little recap from what you guys did in SHS. So if you remember, if you want to find the equation of a line from SHS, you need what? A point, and you need a slope, right? Now, what's the idea? What's the reason behind what a slope? The slope gives you what the direction of the line. So with a point and with a slope, we can find the equation of the line using the formula y minus y1 equal m into bracket x minus x1, where your x1 and y1 is a point on the line. So with the points and the slope, we can find the equation of the line, right? Now, at times we're not given the slope, we may be given 2 points. Now the 2 points can help you find the slope, and with the slope and one of the points, you can still find the equation of a line, right? Now this is what we call the cartesian form of a line. So when you find the equation of a line, so the form ax plus and by plus c equals, you call this what? The cartesian form of a line. What we are interested in model 3 of math 1 to 3 is we are interested in finding the vector equation of the line. There are two different stuff. So the cartesian form of a line looks at the equation of a line in terms of x and y. The vector form of a line looks at the equation of a line in terms of what? In terms of vectors. So to form the vector equation of a line, you need a position vector on the line, or a point on the line whose position vector is some a, right? And also need what we call a direction vector. So your direction vector acts like the slope. So to find the equation of the line, to find the vector equation, you need what? The direction vector d, and you need the position vector what? A. Now what's the direction vector? A direction vector is any vector that is parallel to your equation of a line. So if you know that the equation that you're looking for, the equation of the line that you're looking for, is parallel to some vector d, that means the vector d acts as the direction vector of the line. Okay, so the equation of a line therefore is giving us some r equal a plus some lambda d. Now your r is the set of points. They represent the x and y components, right? The x and y. Your a is a point on the line. Your d is the direction vector, and the lambda here is just a parameter. Why the lambda? We are saying that your line is parallel to the direction vector, so it's a scalar multiple of that direction, and that's what the lambda is. So to find the equation of a line, you need a point and you need what? A direction vector. Now let's take a quick example. Suppose the direction vector of a line is, let's say, 3i plus 4j, and the point on the line is, let's say, I plus j. That means the equation of the line is giving us I plus j plus some lambda 3i plus what? 4j. This means the equation of the line is giving us 1 plus 3 lambda I plus 1 plus 4 lambda j, and that tells you what the equation of this line. It's as simple as that. Now there are times that you may not given the direction vector directly, but you'll be given, let's say, 2 position vectors or 2 points of a line. So finding the equation of a line given 2 points or position vector. So it means that at times they won't give you the direction vector, they'll give you 2 position vectors, let's say a and b, right? So a and b are 2 position vectors on the line. Now in that case, it means that you have, let me draw it so that, let's say you have this your line, you have the vector b and the vector a on this line. So this is your position vector a, this is the position vector b, right? Okay, this is your origin O. So you're looking for the equation of this line, right, given these 2 position vectors on the line. Now to find the equation of this line, now you need to find the direction vector. Now what's your direction vector? Your direction vector here was now going to be the vector what? AB. Remember, this vector what AB, or vector AB is just going to be what vector AB is just going to be AO plus what OB. So it means that what, the vector AB serves as the direction vector of this line. You see, it's moving the direction of what, of the line. So if you have the vector AB, which is given as B minus A, that means your direction vector here is just what, the vector AB, which is B minus A. And so equation of the line R will be given as, you take one of the points, let's say A, plus some parameter T times what, B minus what, A. That where your B minus A is what, is the direction vector. You can also, you could have chosen what, the point B, and with that direction vector in another scale, you can still find the equation of the line. So that's how to find equation of the line, giving us 2 points, right, on the line. Okay, let's take an example again. So let's take this an example. Suppose we want to find the equation of the line passing through the vectors 2i plus j and 5i plus 4j. So if you want to find the equation, you know that what, the equation of the line that you're interested in passes through these 2 points. So that means your direction vector is just going to be what, this vector minus this vector, and with one of the points you can find the equation line. So from here, the direction vector is just going to be 5i plus 4j minus some 2i plus j. So your direction vector is going to be 3i plus 3j. Now take note of this. Now you realize that here the direction vector is what, is 3i plus 4 is 3i plus 3j. Now with the direction vector is just any vector that's parallel to the line. So we are interested in the simplest form of the direction vector, because we just need that direction vector for the direction of the line. We don't need the whole vector and its magnitude. So we are going to pull the 3 out, so that we'll simplify to get what, I plus j. It means our direction vector that we choose for the line that we're interested in is what, is I plus j. So it means the equation of the line is going to be 2i plus j plus some parameter t of I plus what, j, and this represents what, the equation of the line. Now the second part of the question says that the equation of the line passes through the point 2i plus j, and it is parallel to a line passing through what, 5i minus 4j and 2i plus 3j. So it means we are looking for a line, right? Let's say this is the line you are looking for. Let's call this R, right? Now the line that you're looking for passes through these points. Let's call it 2i plus j, and the line that you're looking for is also parallel to another line. So let's draw this line, and that line, that's the line you're looking for is parallel to, also passes through this particular point, 5i minus 4j and 2i plus 3j, right? So it means that what, if I know the direction vector of what, of this line, I can also know the direction vector of what, of my line, right? But because this line passes through this point, I can find the direction vector. This direction vector is going to be this vector minus this vector. So it means the direction vector I'm interested in is just going to be 2i plus 3j minus 5i minus what, 4j. So it means I'm going to get minus 3i minus 7j, I guess. So it means this is my direction. So my direction vector I would choose would be 3i plus 7j, means I've pulled the negative one out. So this becomes what, the direction vector of this line. But remember, the direction vector of this line is parallel to what, this line. So the whole idea of a direction vector is that it is parallel to the line. So if I have a vector on this line which is parallel to this line, means that vector becomes what, the direction vector of what, of this line. That means my equation of the line R is just going to be a point. This point 2i plus j passes through the line, plus my parameter t times the direction vector I just found, is what, 3i plus what, 7j. All right, so that's how you go by what the questions like that. So essentially what we've done right now is finding the equation of a line, find the vector equation of a line, given a point and a direction vector, or given 2 points on the line, or given a point and what, another line parallel to what, the line that you're interested in. Okay, so thank you, like our video, and please subscribe.